Alright, suppose that there is a placement test where the mean score on the math placement test for a certain community college is 71 and the standard deviation is 12. We'll assume that the scores on this math placement test are approximately normally distributed. And the first question is, what's the probability that a randomly selected student scores above a 90? So again, there's a mean of 71, a standard deviation of 12. We're assuming that scores are normally distributed. What is the probability that a randomly selected student scores is 90 or above? So our model here is normal with a mean of 73, standard deviation of 12, and we're looking for x is greater than, probability x is greater than or equal to 90. So we can go ahead and draw this out. Here's the mean plus or minus 1 standard deviation. We're looking for the area to the right of 90. So one way to do this is to go into StatCrunch. To go into stat calculators, normal, and then enter the information of the mean, standard deviation, and then x is greater than or equal to 90. You should get 0.057. So the probability that a randomly selected student gets above a 90 or above on the math placements test is 5.7%. Okay, so the next question is, what is the probability that 36 randomly selected students have a mean score of 90 or above? And as you would imagine, this is a less probability that there's a mean score of, with 36 students, that they get a mean score greater than 90. All right, so we have the mean of all of the sample means, or the expected value for the mean, would be 71, and the standard deviation, also called the standard error, is standard deviation 12 over the square root of 36, which is 2. So our model here is the normal curve, because first of all our population was normally distributed, but now we have a sampling distribution of the means of n equals 36 students, a sample mean of 36 students, and we're finding the probability that the mean score is greater than or equal to 90. All right, so if you plug this in again into StatCrunch or into your calculator normal CDF, and you get the probability of greater than or equal to 90 is 1.07 times 10 to the negative 21st. That's basically a decimal point with 20 zeros in front of it and then a 1. That's pretty much 0 probability. So we would say that there's almost no probability, there's almost a 0% probability that 36 randomly selected students would get a mean score of greater than 90 or more.